For Math 147, the textbook we're going to use is Technical Mathematics with Calculus from Coulter, Rate, and White. For the purposes of this course, we're going to be doing number types, numerical operations, order of operations, scientific and engineering notation, units of measure, and substituting into equations and formulas. We will not be doing percentage. And as you can see, these topics coincide with the first 3 lessons for Math 147. Let's see what happens when we take a look at decimal position values. And this is based on power of 10. Now, 0 is excluded from this because 0 is special. But when we start taking a look at 10 to the power of 0, or anything to the power of 0, that means ones. So whether you have 10 to the 0, 7 to the 0, anything to the 0, that's going to always give you 1. But let's go up in powers of 10. So 10 to the 1 means 10. If we have 10 to the second power, that's 10 times 10, which is 100, which is our hundreds place. If we look at 10 to the 3, that means 10 times 10 times 10, which is 1,000. 10 to the 4th is units of 10,000, because that's 10 times 10 times 10 times 10. If we go down in powers of 10, and we say 10 to the minus 1, that's tenths. So 0.1 is 1/10. If we go down a further unit, 10 to the minus 2, that's hundredths, because this 1 here represents the hundreds place. If we do 10 to the minus 3, which is our thousandths place, that means that this position here is 1,000ths. So 10 to the minus 4, this is our tenths, hundredths, thousandths, and this is our 10,000ths here. The opposite of a number means that if you add a number to its opposite, you'll get a sum of 0. For instance, 2 is 2 units to the right, and if we add 2 units to the left, we add up and get 0. And this is done by 2 plus negative 2, which is the same thing as 2 minus 2, which gives you 0. Also, minus 6 is 6 units to the left of 0. Positive 6 is 6 units to the right of 0. So when we add these two, these balance and give us 0. Now there's symbols of equality and inequality. If you say A equals B, that means whatever number such as 3 that may be in A, B also has the same value. If you have A is not equal to B, this might be a 3, this might be a 5, which means A which contains 3 and B that contains 5, these numbers are not equal. If you have numbers like 3 here and 2, that means that A, which is 3, is greater than what's in B, which is 2. And I think you can see that if we put a 2 here and a 3 here, what's in A is 2 and what's in B is 3. A is less than B because 2 is less than 3. And if you say this, you might have something like 1.999 might be almost the same as 2. So when they're very close, you can say it's approximately equal to. Now when we take a look at absolute value is given by what's in vertical bars. So if you have minus 3, the absolute value of minus 3 is positive 3. If you have 3 inside these vertical bars, that's equal to 3. So really what it's saying here, it's the magnitude of the number defined as its distance from 0. This is 3 units to the left, but the magnitude of that is 3 regardless of the direction. This is 3 units to the right, but again it's 3 units from 0, whether it's to the left of 0 or to the right of 0. Absolute means what is the total distance from 0 to that point. So for instance, if we're giving this minus 3 minus 8, we have to then say this is minus and then 3 minus 8. Figure out what 3 minus 8 is, which is equal to negative of minus 5, which is equal to negative 5. Let's look at the concept of approximate numbers. Now counting numbers like 1, 2, 3, 4 are all exact. However, when we start measuring things, such as a shaft, there is going to be a degree of inaccuracy. Now it says here that the shaft is approximately 1.75 centimeters. Now that is because the measuring instrument that we use to measure the diameter of the shaft has divisions only to the nearest 1/100th. It has no more accuracy than that. Anything else is guessing. So to the nearest 1/100th, we get 1.75 centimeters. However, if we take a look here and apply our rounding rule, 1.745 would still generate 1.75 when rounded. Also, the maximum number, 1.754, would also generate the same 1.75. So the rounding rule says that if the next digit is 5 or bigger, this increases. That's why we have 1.75. But here, if we have 1.75 and if the next digit was 4, this would still give us 1.75. So there's a range of inaccuracy here because this can only give you a measurement to the nearest 100th. Significant digits really tell us how much accuracy a value has. Now if we take a look here, we've got 497.3. Each one of these digits is non-zero, so each one has significance. That's why we have 4 significant digits. In this case, 37.8 has 3 significant digits because we have 3 significant digits written down. In this one, leading zeros are not significant, so we only have really 1 significant digit of accuracy. And this is to the nearest 1/10th, 100th, 1,000th, 10,000th. But even though it's very precise, the accuracy is only 1 digit of accuracy. Again, since leading zeros are not significant, we only have 3 significant digits accuracy here. Again, 3 significant there because these leading zeros have no meaning. However, zeros that are between 2 non-zero numbers do have significance. That has 4, this has 3, and this has 5 significant digits of accuracy. Now in this case here, zeros to the right of the decimal point are significant because if you didn't put it in, it means that your instrument has less accuracy. So in this case, it's to the nearest 100th. If your measuring instrument is to the nearest 100, you write 8.50. And therefore it has 3 significant digits. Now in this case, this one is accurate to the nearest 10,000th, and this is really saying here that we only have 2 significant digits of accuracy. Now what's implied here is if you have zeros without a decimal point, then only the non-zero digit is significant. That's why we have 1 significant digit here. However, this one has a decimal point, so that means that all of these zeros become significant if you include the decimal point. Now notice this bar that's on this 0. That means everything down to including the bar is significant, but the other zeros aren't, so that has 3 significant digits of accuracy. Let's take a look at rounding. If we're rounding to the number of decimal places, we're really talking about precision of a number. If we're rounding to significant digits, we're talking about the accuracy. Now the way the rounding rule works is if we want to round to 3 decimal places, then we have to look at the 4th decimal place. If the 4th decimal place is 5 or bigger, we increase that, but since 4 is not 5 or bigger, our number here is going to be 4.365. If we want to round to 3 significant digits, then we have to look at this number here. Since the number is 5 or bigger, that means this is going to be 4.37. Let's just pick this one at random. So if we want to round this one to 3 decimal places, we have to look here. And is that number bigger than 5? 5 or bigger? And the answer is yes. That's why we have 1.765. But if we want to round to 3 significant digits, then we look at our 4th significant digit, and because that's not 5 or bigger, our answer here is 1.76.